This new unit that we're about to begin is all about transformations. And in this lesson specifically, we're going to take a look at one type of transformation, and that is a vertical shift. And when we say transformations, we're talking about the transformation of graphs or the transformation of equations. Literally moving an equation from one spot to another. So the first transformation that we do want to look at is called a vertical shift. A vertical shift can move a function either up or down. Formally, a vertical shift is described as follows. To shift a function up c units, here's the notation that we write it as: y equals f of x plus c. All this is saying is this: I have a function y equals f of x. All the f of x piece means is that y is a function that is dependent upon x. So I have y equals some chunk of information that has x's in it. And take a look. If I want to shift my function up c units, c stands for any value that we would want, I simply add that value to the end of my function. And if I want to shift it down c units, same exact thing. I have y equals some function in terms of x, and I simply subtract that c value from the end of my function. And what that'll do is that'll take the graph of this function and literally move it up or down the specified number of units. So let's look at our first example here. We've got a linear function here, f of x equals 2/3 x minus 4. Here's what I want to do. Notice how it says this: perform the indicated vertical shift. Additionally, graph both the original and shifted function on the same coordinate plane. So I've got my original function here that I'm working with. I want to graph it. I know to graph a linear, I start with my y-intercept at -4. And from that -4, I use my slope of 2/3. So that's up 2 over 3. Up 2 over 3. I could also go down 2 and over 3 just to get some both directions. And let me draw that a little bit nicer. Okay, there's my linear equation. Now it says that I want to take this function and I want to move it up 6 units. I want to move it up 6 units. So following the pattern that we saw, we simply take our function f of x equals 2/3 x minus 4, and if I want to move it up 6 units, all I do is add 6 to the end of the equation. Now what I want to do is I want to simplify this equation with adding 6. So that's f of x is equal to 2/3 x, and then -4 plus 6 is positive 2. We now want to take this new shifted function and graph it as well. Notice that my y-intercept went from -4 up to positive 2. It simply took this point right here and shifted it up 6 units. And notice my slope didn't change at all. Up 2 over 3. Up 2 over 3. So what I have here is I have another function where at every single point the function has been shifted up 6 units. Two things that we need in the homework packet: you need the new function that has been shifted, simplified, and then you also need the graph that has been shifted on the coordinate plane. So let's look at some vertical shifts in the context of an exponential equation now. Let's first remind ourselves of how to solve an exponential equation, or rather how to graph an exponential equation. To graph an exponential equation, first off, it's exponential because the variable x is in the exponent location. Okay. To graph an exponential equation, we start with that last value, which is our horizontal asymptote. So up 1, 2, 3, 4, 5, 6, and I'm going to do a dashed line for my horizontal asymptote. Now, I know that I either am leveled off. I know that the two options are going to be like this or like this, which means I don't have any x-intercept, but I do have a y-intercept. To find my y-intercept, I plug 0 in for x. So when I do that, plug 0 in for x, that's 0.85 to the 0 power, which is 1, times 4, which is 4, and then plus 6, which is 10. So I know my y-intercept right here is at 10. Additionally, I also know that I start high and I go low because my base multiplier value is less than 1. Okay, so quick reminder of how to graph the exponential. You might have to go back in your notes or watch some of the other videos if you don't remember some of those details. But we now want to do a shift. We want to take our original equation, g of x equals 4 times 0.85 to the x plus 6, and we want to shift it down 9 units. To shift something down, to shift an equation down, we subtract from the end of the equation. So we want to shift down 9, so I'm going to go minus 9. Rewriting this, I get g of x is equal to 4 times 0.85 to the x, and then 6 minus 9 is negative 3. So here's the new shifted equation. What does the shifted graph look like? Now, we could just try to graph this new equation right here. However, there's a simpler way to do it. What I'm going to do is I'm going to take every piece on this graph here that I know, and I'm simply going to move it down 9 units. So if my horizontal asymptote is up here at 6, it's now down here at negative 3, shifted down 9 units. And if my y-intercept is up here at a 10, shifted down 9 units, it's now at 1. And from there, I can simply copy that graph. It has simply been shifted down 9 units. And so there's the new equation and the new graph shifted down 9 units. So there's 2 more equation types that I want you to see a vertical shift operating in. This third one is quadratic, another equation that we're used to or have graphed in the past. So I've got h of x equals negative 2 times x minus 4 squared plus 2, and I'm supposed to shift it up 7 units. Now, this I know it is a quadratic because I have an x that's being squared. But it's in vertex form. So let's go ahead and graph this to see what the original graph looks like. When we're in vertex form, we remember that our vertex is at hk. So my vertex, but I have to remember opposite inside the parentheses, so it's actually at 4, 2. My vertex is going to be at the point 4, 2. So go over to 1, 2, 3, 4, up 2. Now from that point, because my first value here is negative, I know that my graph is going to open down. If my graph opens down, I know that I'm going to have x-intercepts. So let's find the x-intercepts of this equation really quick. To find x-intercepts, plug 0 in for y. So 0 equals negative 2 times x minus 4 squared plus 2. I need to solve this for x. I'm going to subtract 2 from both sides, so that's negative 2 equals negative 2 times x minus 4 squared. I'm going to divide the negative 2 away. That's 1 equals x minus 4 squared. I'm going to undo the square with a square root. But when I do that, don't forget, whenever you undo a square with a square root, the other side gets a plus and minus. Square root of 1 is 1, so that's positive and negative 1 is equal to x minus 4. Last step, I'm going to add 4. So I'm going to add 4 here, but how I'm going to do it is I'm going to do 4 plus and minus 1 equals x. So 4 plus 1, that gives me x equals 5. 4 minus 1 gives me x equals 3. Good. So I know at 3 and at 5 are my x-intercepts. So I'm going to draw my quadratic facing down there. I'm going to label that point as 4, 2. I'm going to label this point as 5, 0. This one as 3, 0. So I've got my original quadratic graph now. These are the ones that take some time. But now I need to take that original equation, h of x is equal to negative 2 times x minus 4 squared plus 2, and it says I need to shift it up 7 units. So I'm simply going to add 7 to the very end of my equation. So that now gives me h of x is equal to negative 2 times x minus 4 squared plus, in this case, 2 plus 7 is 9. So this would be my new equation shifted up 7 units. What does my graph look like shifted up 7 units? Well, I'm going to take each of these points, the y-intercepts and the vertex that I know, and I'm simply going to move it up 7 units. 1, 2, 3, 4, 5, 6, 7. Same here. 1, 2, 3, 4, 5, 6, 7. Same here. 1, 2, 3, 4, 5, 6, 7. Everything has simply been shifted up 7 units. There's my new graph. The new coordinate here is 4, 9. Here we've got a 5, 7. And here we've got 3, 7. So there's my initial equation shifted, and now my graph shifted. So last example of the type of equation that I want to see us be able to do vertical shifts with is, as you can see right here, a radical equation. I know it's radical because the x is under a square root. I'm supposed to take this equation and I'm supposed to shift it down 11 units. But let's graph this initial one. Well, hopefully remember that all radical equations have a starting point. And that starting point, again, is hk. But I have to think opposite on the piece under the radical. So it's negative 5, 7. There's my starting point. So negative 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. Negative 5, 7 is this point right here. Okay. Now from that, I know that I either go up and out, or I would from that point go down and out. Okay. The question is which one? Because I'm positive in front of the square root right here, I know that I go up and out. So I go up and out, which means I know I'm going to cross the y-axis right here somewhere. So how do I find my y-intercept? Plug 0 in for x. So that's going to be the square root of 0 plus 5 plus 7. So that's the square root of 5 plus 7. And doing that really quick. Square root of 5 plus 7. I'm getting a 9.24. So my y-intercept is a 9.24. It's about right here. So I'm going to go up and through that point and slowly begin to level off. Now the goal is to move this down. So let me label this really quick. This is at negative 5, 7, and this is at 0, 9.24. We want to shift it down 11 units. So I take my original equation, j of x equals the square root of x plus 5 plus 7. To move it down, I simply subtract 11 from the end of my equation. So that's j of x is equal to the square root of x plus 5, and then 7 minus 11 is negative 4. So it's x plus 5 minus 4. So here's my new equation shifted down. What does the graph look like shifted? I simply take each point and I move it down 7 units. Down 11 units. So if I'm up here at 7, moving it down takes me down to negative 4. If I'm up here at 9.24, that brings me all the way down, okay, from 9.24 minus 11 to negative 1.76. Negative 1.76. And from there, I can now copy that shape. So negative 5, negative 4, and this is 0, negative 1.76. And so there's now the graph shifted down.